Okay, moving right along, we're going to start the morning's, the second session of the morning. We have two speakers. The first one is Charlie Saltzman from Gulfstream. He's going to talk about 3D electronic model-based type design, and if you're good, maybe he'll give you a ride in a new G650.
Ooh, maybe not. Well, I'll tell you, these will be some hard acts to follow. I was discussing back there with Beth earlier. I said, I'm going to bring this intellect way down as we go through this. Just a little background. First, you'll see Jeff Kreide's name on the presentation here. He ended up being called away, so I got the duty to come out here, and I really appreciate having the opportunity to speak this morning. A little history on me personally. I'm an operations man. I am not an IT guy. I am not a computer guy at all. Not a code writer, but in fact a manufacturing guy who has found himself over the course of 31 years at Gulfstream in the role now of being in charge of the product lifecycle management group, which is really has afforded me some eye-opening experiences here in the last 6 or 7 years going through the development of our new flagship aircraft. So just a quick overview of the company. Many of you may know that General Dynamics bought us several years back, and we are part of 4 companies that they own, IS Combat Systems and Marine Systems. I'm not sure. Can you guys hear me okay? Okay, and of course us. We are a $6 billion entity within the General Dynamics system, so we do quite a big business there, and especially in today's economy with government spending being what it is, I think that we provide those guys some good benefit. If you look at what Gulfstream really wants to be and do and strive and be known as, we want to be the leaders in the corporate business jets. In that world, in that space, we even talked, Beth and I have been chatting back there as we went through this morning, and we do actually sell a lot of special missions aircraft and a lot of aircraft to the United States government that don't get quite the notoriety that a lot of these aircraft that you normally see. A quick look at our product line. Historically, I'll go back to Grumman moved to Savannah in 1967, and we were a single strand. The G2 was being manufactured then. The G3 come online there in the early 80s, and still we remained a single strand company all the way through the inception of the G5 in the late 90s. When it come online, that really changed. The G4 was still selling well, and we have since become quite a diverse company. If you look at our product offerings now, the 150, the G280, the 350 and 450, the 500 and 550, and of course our latest and flagship aircraft, the G650, entering into service at the end of last year. The 650 really is a nice airplane and a much larger aircraft than the other ones, though it doesn't necessarily look like it there. We have a very, very nice range, and the airplane can really move. I mean, we cruise at Mach 0.85, but the aircraft will, it does pretty well. It can exceed that. If you look at our footprint in just the United States, Gulfstream has headquarters in Savannah, Georgia. You may notice the accent, but we have sites all around the country, outfitting sites and service sites, as well as a fabrication facility down in Mexicali, Mexico. In the last couple of years with some acquisitions, now we have service facilities scattered around the world. getting into the 3D model-based type design, we started this in our outfitting. And really, the schedule and pressure, we were really selling a lot of airplanes. And if you look at the way we outfitted airplanes, a lot of highly skilled craftsmen, tribal knowledge, the whole deal. We were constrained by the workforce as far as the skills go. We were selling airplanes. We could even engineer the airplanes and keep up. But as far as getting them out, we were really getting hamstrung. So we needed to come up with a different way of doing business, a different business model. So we went into an effort to try to, if you will, enter into an agreement with the FAA on this model-based type design. And it took several years to get through, but really that is where we come up with the processes and the plan to integrate as we went into the G650 and the entire program. That 650 program was our first, Gulfstream's first clean sheet of paper design. All the other aircraft were iterations, if you will, of the previous airplane. So the 650 was our first shot at a clean sheet, and we wanted to make sure that we were in a position to use these new processes. So what is 3D model-based design? It is a true electronic representation of the aircraft, including everything from fasteners to the hardware and veneer inside the airplane. I mean, every bit of it is modeled. And what we do from there, our group, the PLM group, is make sure that we take that representation and leverage it downstream to our manufacturing and service, the procurement, and even out into our customer base. So it really relies on geometry rather than text. There are no dimensions on our models. So the end users interrogate the models for whatever they're looking for. If you look a couple of quick shots here of a forward fuselage of the 650, you can drill in a little deeper here. You can see the complexity just at this level. And it's interesting when I look at the high-speed computing aspect of what we do and what we need to do moving forward, that the things that are slowing us now are in your guys' space. Quick shot of the aft fuselage and the tail. One of the things we were concerned about as we began on this journey was, would the guys on the floor, would the mechanics, would the people in procurement, would they be able to come up to speed and understand how to not only interpret, now we were leaving the paper world and use manufacturing execution systems. We actually use, I'll just put a plug in for Solumina, we actually use that as our MES. But not only train those guys in a new MES system, but to go in and interrogate our CATIA models and understand what they're looking for and get to those particulars out of that. And we really underestimated those folks. I tell you, not only did they just think it was cool, they really grasped what they needed to do for their particular parts of the job, and we picked it up pretty quickly. One of the things when you think about key initiatives here with 3D model-based design, and this may, especially for any of the manufacturing folks in the room, is probably not any earth-shattering news. Standard parts was a big initiative there. We had, and on the 650 compared to the 550, we had 50% reduction in part numbers on that airplane. In outfitting alone, the old ways of outfitting our interiors on the 550 and the 450, we reduced down the number of brackets and clips used to hold in our structure, our furniture, from in the neighborhood of 400 to 500 to around 6. And if you understand that, you guys in supply chain management understand what that does for you. I see the Boeing guy shaking his head. Absolutely, that is a big deal. Our configurations are maintained by aircraft in 3D. We can get out of our system on-demand bombs. The end user anywhere in there can pull up the electronic copy of the engineering bomb. This really lends itself to be able to use a lot of NC programming and precision manufacturing on the shop floor. We've got our new building and we've taken some small steps, I'll say, in the Gulfstream world into the robotics. And we're actually feeding right out of these 3D models the information to that. So really making some strides in our manufacturing processes. When you go into the electronic world, especially in aerospace, really we need to maintain our data for 50 to 75 years. What is the life cycle of that aircraft? So in order to do that, what are things you've got to consider? As we go through our processes and solutions, if you will, we have to make sure that we can get our data regardless, software, hardware, we know that changes like the wind. So we need to be able to get our data, our IP, back out of that long term. How do we know, if data goes corrupt? How does the users know? How do we convince? We actually have with the FAA an agreement to design and manufacture our airplane in this space. So we had to convince those guys that we had that covered and we had solutions that would handle that. So when you look at what we do, just at a top level, we check our data every night. We go through every bit and byte of that data so we know the next morning we have our reports ready. If anything's missing, if anything's corrupt, it's addressed immediately. When we look at upgrades, we just come through an upgrade of our CAD tool, and that took us about 1.5 years to go through and do the proper, if you will, go through all the metadata, all the geometry validations and everything required to take that data and move it from just from one version of the same tool. From I think we went from R22 to our R19, excuse me, to R22. We're preparing now for the next version of our CAD tool upgrade as well. So it takes a good while to go through and do that, but all of that stuff is documented and in agreements with the FAA in order for us to maintain our business process in this way. When you look at what it takes, and we were talking just at the break around international standards, we spend a great deal of time trying to influence what standards are around this, make sure that we can tweak the software vendors as much as possible as they're coming out with their tools and whatnot, that we can maintain and move our data from one spot to the other, from one tool to the other. When you look at the applications, before they're added to the environment, anybody historically at Gulfstream, and I'm not sure about all of your places, but somebody could call the IT folks up and they say, hey, look, I found this nice, neat software, I want to try it. They would go buy it, put it in, and next you wouldn't hear from them again. Now they have to come to us and go through a really tough testing process to make sure that, that there's no impact to the data long term. Outfitting, when we look at what the impacts to the business, and really we don't build solutions. Gulfstream builds airplanes. We don't build IT or stuff. We build airplanes. So really, when you look at what the impact of the business is, that's what we really try to focus on as we go through our solution development. We really reduced the total cost and cycle time of our outfitting our airplanes. We were running around 12 to 15 airplanes a year just in the G4 and G5 hangars, and now we can run nearly 40. In the year, and that's over the period of the last 7 or 8 years coming through this. 650 again, you look at the standardized parts, really a big reduction in our parts and part numbers. I've got a few pictures here. I told you folks that I was a manufacturing guy. When I hired on at Gulfstream, one of my first jobs on a Gulfstream 3 was joining this nose to that front barrel section. It took us about me and about, I guess, 5 guys, probably in the neighborhood of 3 days, and I hate to tell you all what we did, if there's any airplane people in here, what we did to get that thing to line up, to be smooth, to all the things you need an airplane to be. It took us about 3.5 days to put that barrel section together. When these guys, with the tooling, with the 3D model, oops, I think I have hit a button here. There we go. So with the 3D, let me back up here. With the 3D model-based design concept, the precision manufacturing, these pieces, the nose was set on the joining jig, and we slid it together, and those guys had that airplane joined. This is the first one in 15 minutes. They had all the holes lined up and ready to put the stuff. I'm telling you, it blew my mind. I did not realize the impact that this was going to have on our business. Oops, going the wrong way. Here we go. Okay, you see here, wing to fuselage join. Again, the hiccup in the first join here came at this point. We found a bushing that we traced back to a manufacturing quality error that was not at the right hole size. They pulled it, put it back in, and set the airplane right on. It joined up beautifully. Wing to body fairings, our leadership, this was an area of concern. Complex contoured composite surfaces that they were worried that if there was going to be a hiccup in this philosophy of design and manufacture, we would find it here. These wing to body fairings, the gray pieces you see there going on, we did not oversize the holes. We put pilot holes in, but every one of them lined right up. So really an impressive, I'll say the guys did a great job with the way this turned out, and we were full steam ahead then. So when I look at this, when you look at what 3D model-based design can do for you within a business model, you just got to be aware and make sure data, as you guys well know, is what you own. That's what you need to protect long term, and the hardware and the software applications and whatnot that support that have got to be in line with being able to do that. I think I kept us a little ahead of schedule. There.
Questions for Charlie? Doug Ball.
What a surprise!
What a surprise, Doug Ball.
Okay, so now that you got this full 3D, solid model geometry for the airplane, have you used it to look at manufacturing issues? And I'm thinking of access issues. Can a mechanic actually, how much difficulty are they going to have getting their arm in there to install a bracket or a part or a piece of equipment?
Absolutely.
And the corollary to that, okay, so now we're looking at the human part of it, is are you looking at this now? Is this an enabler for figuring out how to put your airplanes together robotically versus manual labor?
Yes and yes. We in the end.
I did word those questions very poorly. That was my fault.
Well, I'll tell you, Doug. We last year we just got finished putting in a 3D cave. So we have, and somebody and I was talking this morning, they said this was the first practical application they had heard of 3D cave technology, but we've installed some software that allows us to go in with the designers, to go in with the mechanic and work the access issues as far as that goes. So we are doing that, infant stages of doing that. As far as the robotic stuff, we are really scratching the surface on that, though new programs are pushing that technology even more as we go forward, that we will see here in the near future as Gulfstream announces products and whatnot. But we are trying to get further into the robotic side of that, take as much human error out of that as possible. I know that as far as giving our designers 3D capabilities at their desk, we've put quite a few 3D monitors. We deployed them to a couple of whole groups, the different interactive 3D type monitors, and they just don't use them. It's really tough to get those guys to use those 3D monitors. We put the cave in. It's great for design reviews and whatnot, but still the 3D interactive stuff as far as checking for spaces and all, we're just seeing some practical application of that in the last probably 6 months.
Thank you.
Yeah, this was a a really great presentation, but you talked about having a low volume, high mix product line, right? And you're a manufacturing guy. So you've got all these components, so many variations of possible configurations. The impact of that across your manufacturing supply chain part numbers is really, really big. How do you actually solve that problem of figuring out how many parts, what configurations, and how do you solve that to manage the cost?
Well, you can imagine with a new product coming online, there is just iterations, spinning out of control. The change traffic engineering was really tough, but we do maintain our BOM within, we use Smart Team. It's a Dassault product, and I'll just say we have a Smart Team core, and then there is a great deal of customized functionality built around that core to help manage that data with our suppliers. And we have several different tiers, if you will, of suppliers. I'm sure that's not unusual to folks, but we have tier ones that actually come in behind our firewall, work with us within the firewall on their stuff, as well as different tiers outside of that. So all of that is managed within our Smart Team PDM tool with the buyers. Yes, sir.
Yeah, I just wanted to ask if the degree to which you've been able to do more computer modeling and simulation has changed the way that you certify or validate for both government requirements and your own.
Yes, it has. There are ways it has, and then there are still some ways that we are coming up to speed with simulation in the certification side of the world. I won't speak much. We're not allowed to speak too much about this, but everybody knows we had a very tragic accident during the flight test program and lost an airplane and lost some very valuable lives. One of the findings from the FAA was our ability to be able to get those analysis and things. They found that as part of that investigation, that it took a really long time to get through that data, to get that data analyzed, and that is something that we are currently addressing right now. Yes, sir.
You said you check your data every night for silent corruption and file failures. I'm curious as how much data are you checking and how many you find?
A lot and plenty. Again, I'll remind you I'm a manufacturing guy. We have, I'm trying to recall the number of files. We built a process and named it SADI, if you will. But we get an error report every morning that comes up with anywhere in the neighborhood of, I'd say somewhere in the neighborhood of 100 issues just about every night. Some of them big, some of them not. And that's not, I say every night, that's not every night, but I would say on the average week you can find some issues, but I think there's hundreds of thousands of files that we're going through in there. Somewhere in the neighborhood, I believe it's somewhere in the neighborhood of 300,000 files. We had some server issues. I'll just say about 3 months ago. There were some things being put on servers. Maybe not server issues, maybe I should say process issues. Things being added to servers that should not have been added. And since that stuff has been cleaned up, we have seen very little in the last probably month or so. But we were finding a lot of stuff very regular that we just couldn't figure out what was happening, and went back and that our IT groups, again, were putting things on servers that should not have been there. Scanning type software bogging things down. And it got to the point we could not even run our check process at night. It would take almost till lunch the next day. It started creeping, getting longer and longer as time went on, and then we was able to trace those back down and find out what those were.
Okay, very good. Thank you again, Charlie.
Thanks, sir.